So yeah, now we're going to kind of get to the demonstration portion. So what I'd like to kind of start with, kind of showing you a picture of kind of the main concepts in the ontology, and then I will take you from the picture into what the ontology looks like. So flights are historical events in our model, as opposed to like the idea of a flight or a possible future flight. Flights are historical events, so they have a start time and an end time. They have a route code. They have, was there any actual delay, things like that. Flights depart from and arrive at airports. Airports can have routes to other airports, as Thomas kind of just mentioned, and they can have, these routes can have distances, so we can model that. Airports are a type of place in the general sense. Airports is just one of many types of places. Geographic regions, such as cities, states, and countries, are places too. So, this model is just showing that. There's lots of different kinds of places, some being regions, some not, some being landmarks or other things. It's important to note that places can be located within other places. That makes common sense to us as humans. We understand that, if I'm located in Melbourne, Florida, and Melbourne, Florida is located in Brevard County, and Brevard County is located in Florida, then I'm also located in Florida and the United States, etc. So this is something we can put in our ontology, the idea that places can be located in places. We can also even define that located in is something called a transitive property, meaning, like I said, if A is located in B and B is located in C, then the system, if we say that located in is a transitive relationship, the system can infer that A is located in C and on up the chain. And that actually will play into some of the stuff we show you in a minute with the flight demo. So just an example, again, places, so airport can be located in a city, the city can be located in a state, state in a country, etc. So this is kind of the overall model. That kind of pictorially we'll have flights and places, airports they arrive and depart from. We will get into a little bit later the idea that we're going to subclassify and be able to determine what's an international flight and an international arrivals and departures, right? So a subtype of flight, those that come in from somewhere that's not the current domestic country, and some that are leaving from a domestic country to a foreign country based on a certain perspective. So in terms of the data that we're building from, we actually end up with two different data dumps that we used. One was the flight data, one with delays that Thomas mentioned. Another one is an set of airport data that just tells what airports are located in what cities and countries, and what their lat longs are and things like that, what their codes are. So we'll end up building data that looks kind of like this. We'll have, airport located in a city, city located in a country, other airports linked to, again, up through cities and countries, and airports and their routes to each other with distances on the edges. And then we also have that flight data. So there'll be a particular flight. We'll get into kind of the URIs that model these things. Actually, as I hover, you can kind of see that. Because we're using an RDF graph, every one of these things is really modeled with a URI that makes them distinctive and globally shareable. And other people that want to talk about the same Orlando airport could do so by using the same URI. And essentially, so then we'll talk about flights, particular flights that had an arrival and a departure time and maybe a delay, and where they departed from where they arrived at. This is the type of data we'll be building.